Learn a little bit about Python, dictionaries and lists, and comma separated values, and see the very beginnings of machine learning. All right, so what we have here is a famous data set of plant measurements. There are three types of plants: the irises, Iris setosa, Iris versicolor, and the Iris virginica. And the goal is to use these four data values to classify the correct type of plant. Now, perhaps you can see some patterns just looking at the data yourself, but turns out it's not really that easy. In the past, plant experts were used to do this type of classification. Okay, so we have the file in a spreadsheet. It can be exported into what's called a comma separated value file, CSV. And notice that you have all your rows, and each row has 5 objects separated by the 4 commas. So this translates into exactly 5 columns, and we have 150 rows. It looks like we have 50 of each type of plant. Okay, so first is how do we read this kind of data into Python? All right, so let's go to our Python program, and the Python program is a bit long, 77 lines, and it's spread out into various functions. So let's first take a look at the functions. So the first function is print iris data, and it takes one argument, S, and does not return anything. Next, we have the iris to dictionary function. It takes two arguments, S, and number of fields. That's a bit of a long function. And it returns an iris dictionary. And then we have another function which searches for a value, takes an argument Z, and it needs a dictionary. And it returns a list. And another function, check for values. It needs a dictionary. And finally, our main function. So this is the entry point into the program, and this is where things will start. I changed the name to CSV. Before it was data. All right, so let's trace through this program. It's going to be a bit more complicated than usual, but this is important stuff. Starting to understand really how to use dictionaries and files a little better. All right, first, print iris data. So I'm going to modify the program, and so this way we only do a few things at a time. And the way that I could do this, maybe a little better way, is I'm going to put an exit right here. So as soon as it does this first step, it's going to exit. So print iris data. So let's see what happens. Right, so we don't need this for now. Python iris.py. Okay, so we successfully read the file. Right, here's all 150 rows, lines, and we seem to have them. So let's take a look at this function. Print iris data. Notice it takes an argument, a string. All right, so this is the entire function. It's not very long. So we open up the file as a readable file, read only that is. For each line in the data file, if the line is not empty, which means if we didn't get to the end of the file, print line, so print the line we just read, but as we print it to the screen, end it with the blank character. This way, we won't have a double new line character. You know, why do we do that? Because there's really an invisible character here. You can show the special characters somehow. In some of the good browsers, you can reveal the hidden characters. I'm not 100% sure how to do it in this one, but you can search for it here, show invisible characters. Yeah, it didn't seem to show it. So sometimes you can show some of the invisible characters. Yeah. All right, not important. Okay, so back to the so we print each line, and remember there really is a \n at the end of every line. It's invisible. I couldn't get it to show, but we don't want to double print that, so that's why I use that. That's why I ended with a blank. All right, print one more line just so that when we get to the prompt, we have a line here, so it doesn't continue right like this. And let's close the data file. Okay, so that's pretty simple. So let's take this out. All right, next step is I'm going to load the data file into a dictionary. I'm going to comment out this since we don't need to print the data. We're going to reopen it in this function. And then let's see what we just did. I'm going to print this dictionary1. And then I'll exit. Let's see what happens first. All right, so that's our dictionary. It looks a bit of a mess, but if you focus, what you're seeing is these are the keys, and this is the value. So we could do something like, instead of printing out the whole dictionary, you could say for K in dictionary1, print K. Let's see what this does. Oops, sorry about that. Earlier versions of Python, by the way, Python 2, you could do that. So sometimes when I download older Python files, they don't have the parentheses in the print. It's a bit of a pain because I have to go and change them all. All right, so if you just say k in dictionary, it gives you the keys. You could also say dot keys, and this should give you the same result. All right, so those are the keys. How about the values? Let's see the values. So these are the values, and if you want both, you could say, this is pretty neat, something you can do in Python. You can say items. See, this is the key and the value. And sometimes, don't get confused, you don't need the tuple notation. Python knows it's a tuple without the parentheses. So you could do this too. So you could say for kv, but I like to do it this way. So I know that it treats it as one object, but it does that automatically. All right, so we've loaded this into a dictionary. Okay. So let's comment this out and go to our main function, iris to dictionary. So let's see how it works. So it's going to return a dictionary. It takes a string and then the number 4. Why did we send the number 4? Probably something to do with 4 numbers there. Remember, we wrote this function ourselves. All right, so iris to dictionary. Okay, just like before, open the file. I'm creating a list called list version for line in iris data file. So for each line, if the line is not empty, we're not at the end of the file, well, let's clean up the line first. Just in case, let's take out that \n at the very end, any spaces at the end or beginning. So let's clean up the line. Turn that cleaned up line into a list of strings. Each string is separated by a comma. So that's what the split does. And then list version is we'll put what we just did, which is itself a list, into this bigger list. So list version looks like it's a list of lists. So let's see if we can visualize that. So perhaps what we'll do is we'll put there's a nice way to print out lists called pprint. Pretty print. It stands for pretty print. Let's see if it works. And then I'm going to put an exit. Well, let's let it close the file. And then I'm going to exit right here so that it stops. All right, it doesn't know about the pprint. I think we need to import it. So import pprint. Okay. So this is the last thing it did before it exited. And I think I printed out the wrong thing, right? Let's see. Okay, so we don't want to print out line list. We want to print out list version. That line list is only the last line. list version. That's what we want. That's supposed to be the list of lists. All right, so here it is. So you see the double bracket? That's a list of lists. So the first bracket is telling you that each row is itself a list. And each row is itself a list. So this is the first element of list version. This is the second element of list version. And this is the last element of list version. And then this other bracket is because we have a list of elements. Each element is itself a list. So that's okay. Okay, so let's continue. Take out the exit. And let's close the data file so we don't lose anything. All right, now what do we do? Notice one thing, I'll talk more about this. See, this S here is only defined within the function. It does not exist anywhere else. That's called scope of the variable. So iris data file only is defined within this function. You cannot use it in any other function or the main function. See how we call this dictionary 1? That's the name of the dictionary that it will be. That's how we will refer to the dictionary in the main program. But this dictionary 1 is actually iris dictionary here. So we'll talk more about that soon. All right, so we're right over here. So notice that this is not what we want yet, because each element tuple, each tuple here is a string. It's a tuple of strings. We need these to be actual numbers and not string numbers. So we need to convert these all to floats. So let's do that. All right, so for each row in list version, remember list version is this here. For I in range of num fields. Num fields is 4. 0, 1, 2, 3, less than 4. So 0 less than 4 will get all 4 of these. So 0 to 4 will get the first 4 numbers. And we're simply going to change row I, so the ith number, say I is 0, right here, to the float version of I. So that will only work from 0, 1, 2, and 3, and it will not modify the string, which will remain a string over here. So let's see what this now looks like. So rather than print it out row by row, well, all right, let's do this, and I'll exit it right here. The last thing it's going to do is go through each row of list version and print each row. And see, the strings are gone, and now these are numbers. So they're ready for numerical analysis. Okay. Next, let's store this in a dictionary. So we create a new dictionary called iris dictionary. And remember, it only is valid within this function. It will not exist anywhere else unless you do specific steps to make sure that it's available to other parts of the program, which we will do. Okay, so declare our dictionary. For each row in our list of lists, in our list version of the CSV file, create a tuple. Dictionaries cannot use lists as keys. Remember that, it's important. They need tuples or regular primitive data types are also fine. So let's turn each row to a tuple. Notice I'm going from 0 to less than, strictly less than 4 num fields. The reason I'm using num fields instead of 4 is, let's say my next file has 19 different fields, right? So you don't want to have to rewrite your program, and you just have to change I just have to change one line. Change this 4 to a 19, and then the whole program will work fine. Alright, so let's see, where were we? Okay, creating our dictionary. Alright, we made our tuple, and then put the tuple in the dictionary. Now, I'm actually cheating a little bit here, because what if, and this is common in machine learning, what if the same tuple had two different values? In other words, what if there were two identical measurements that gave different or maybe even the same classification? This is the classification, this last column. The way that I'm doing things here, I would lose the multiplicity. I would lose that. So in that case, it wouldn't really make sense. In real life, you wouldn't want to put this in a dictionary. You would rather keep it in this form. This list version that I have here is probably better for that kind of thing. But my purpose is to illustrate dictionaries, so I'm just warning you about that drawback. Alright, so store my tuple with the current last element of the row. Remember, 4 would be the 5th element. Okay, so we have our dictionary. So let's see, let's print the dictionary out, and then we'll exit just to see what it looks like. So here's the key and the values. Okay, now remember I said that this dictionary only exists within the life of this function. So if you want the dictionary to keep on existing, in other words, you don't want Python to delete the memory that's taken up by that dictionary, then you need to pass it on. So on returning this dictionary, what you're really doing is you're returning the memory address. If you want to see what that looks like, it's not so easy to see the memory location. I don't know the actual Python command, but in other languages there's an address. You can see the address of a if you're interested, you can search that, how to find the address of a variable. So when you pass this dictionary, this could be a huge dictionary with millions of data elements. you don't want to actually make a copy of it, so you're passing it by reference. So the memory address of where this dictionary lives goes back to right here and ends up in dictionary 01. Okay, so now we have our dictionary in the main program. It's back. Our last function is called check for values. So let me show you how it works. This is the last part of the program, so I'll run it. So we did everything we've done. We've already explained everything so far. And it asks me to enter a float. So let's say I enter the 5.9. What it does is it gives me all of the elements of the dictionary where 5.9 is a part of the key. So is 5.9 part of any of the rows? And as you can see, it gave me 5 rows that have a 5.9 in it. How about 1.8? Well, a lot have 1.8. How about 1.0? How about 99.2? None found. How about 9? How about 1? So it knows that 1 is 1.0. It can convert things. Alright, so you see the idea? We simply look in our dictionary for the values that have the requested value. So let's see. Check for values dictionary. Alright, so this little function here has one argument and a dictionary. Any dictionary will do, and it will put the actual dictionary in there. So we've passed it to this function. All right, enter a float. Let's read a float from command line. As long as we didn't enter the blank float, right? That's how we end. So if you just hit return, it ends. My list equals search for value Z a dictionary. All right, so this is a new function. So I pushed off some of the work into this function. But let's continue and we'll go to this function last. So what does this function do? Well, it returns a list of the found values. If it actually has anything in this list, if the list is not empty, print we found the item, and for each element in the list, print that element. So that's what it did here. Found the item, here are all the elements. Else, print none found, and let's get our next value. And it'll do this until you enter just the return key, a blank string. All right, so here's the key. How do we find values? So this function takes a number, Z, and a dictionary. So it's right over here. So let's see. Notice you can use a different name. We're just substituting the dictionary into this variable. Now I called it diction A. All right, list to return. We're going to send that list back. It's empty now. For each ordered pair in dictionary items, if Z is in X. So remember, X is a tuple of the keys, right? X represents 4 numbers. is z, the number we're looking for, one of those four numbers? If this is true, it'll add that complete dictionary key value pair to list to return, to this list here. It went through the entire dictionary and it did this, and then it returned this list. And then we already saw the list got here, and then we printed out the size of the list. All right, so once again, 2.5, 3.5, 4.5, 5.5, 6.5, 7.5, not found. Hit the enter key and we're done. Okay, so this is the elementary part. That's, notice you have to call the main function, so without this, nothing will happen. See, if I turn this off, nothing happened. This is the entry point right there. Okay, now, next time, in a little while, when we get more serious about the machine learning, artificial intelligence part of this course, we'll start with something very simple. Oh, so here are my invisible characters. So let's see if I can get them to open up. Nope, they're not meant to be. Okay, so here are the invisible characters here. This must be the new line characters. See, these are tabs. So let me turn these off. So you usually don't want them. And as you can see, this program's a little quirky. I just tried to turn them off and they're still there. Now they're gone. All right. So this next program is called the KNN. And what it tries to do is classify various flowers by using other flowers to see what's similar to those flowers. So let me show you how it works. Python KNN flowers.py. Alright, so what it does is it splits the data set into two parts, a training set and a test set. So remember, there's 150 elements. There seemed to be one short for some reason, maybe just the counting, but there's 150 elements, so it splits them into about 90 versus 60. It uses these 88 to train, and then it tests our system with 61. This is called a lazy learning system. What it does is it uses these 88 training set to learn how to classify flowers, and with the remaining 61, and these are randomly generated, it tests the prediction. So let's see how it did. So there's 61 in the test set. It predicted, see, as you can see, it looks like it's getting it right. This one looks like it's wrong, see? It predicted Iris virginica, and the answer was actually Iris veriscolor. Now, later on we'll learn how to do this with a neural network, though we'll do a much more complicated program than this. But this will be the very beginning of machine learning. So how does it work? What it does is, you see these data values? Let's say this is a test data set. It finds the closest 3 elements that it already knows how are classified. So let's say it used these first 4 to learn. Now it gets to this 5th one. It'll say, which one of these is most similar to this one? It'll basically use the distance formula between points in a plane, but a higher dimensional version. And it'll see which one of these is it most closest to. Now, it may not just use 1, maybe it'll use 3. It'll say, which 3 is it most closest to? And it'll use that to decide how to classify this one. So just very quickly, if you want to see what this code looks like, it's quite a bit more complicated. And we're going to go through this in another screencast. Notice there's a better way to open up CSV files, and that's with the CSV library. You could do this in one line. So we'll get to this another time.